TJB Coal-Fired Power Plant Unit 3 and 4, located at Central Java, Jepara, is a coal-fired power plant which has 1,320 megawatt capacity in total, while TJB Unit 1, 2 of same capacity were constructed earlier and in operation now by another company. Bituminous coal, which is used as a fuel, is transported by 70,000-ton Panamax vessel from Kalimantan and is unloaded by 2 ship unloaders installed at the coal jetty. Such coal is transported by belt conveyor and stacked by 2 stacker reclaimers in the coal yard, whose storage capacity is 660,000 tons. Coal stored in the coal yard is forwarded to the coal silo through stacker reclaimer, conveyor, and tripper. The pulverized coal, which has been crushed from the pulverizer, will be burned after being input into the center of the boiler through the coal nozzle of the wind box after going through 4 coal supply pipes, with preheated air at the regenerative air preheater. TJB number 3-4 power plant boiler is a drum-type circular ultra-firing, low nitrogen oxides combustion system which uses the variable pressure operation when in partial load with single-stage reheat, balanced draft, high-pressure turbine bypass system. This boiler produces 2,285.5 tons of steam per hour when in maximum continuous evaporation, 175.3 bar pressure, 541 degrees Celsius steam by burning coal of 278.5 tons per hour per unit. The boiler's heating surface layout should be in order of primary RH tube, secondary SH tube, tertiary SH tube, secondary RH tube, tertiary RH tube, primary SH tube, economizer to the direction of the exhaust gas flow. The capacity of steam turbine of TJB number 3-4 power plant is 708.3 megawatts, each which is impulse type, 4-flow exhaust, 3 cylinders, reheat condensing turbine, and 3,000 RPM rotation. The high-pressure superheated steam goes through the main stop valve and control valve into the HP turbine and goes into the reheater after extracting its energy from a fluid flow into useful work through 14 HP stages. The steam which has been reheated in the reheater goes through the reheater's stop valve and the intercept valve into the IP turbine. After it goes through 16 IP stages and passes the single crossover pipe, the half goes into the LP turbine A and the other half into the LP turbine B and condensed in the condenser after going through 24 LP stages. Generator is directly connected to the turbine shaft and rotates at 3,000 RPM. It has 3-phase, 50 Hz, 22.8 kilovolts, 0.9 power factor, 4.4 bar hydrogen pressure at 802 megawatts rated capacity. Water is used for stator winding cooling, while hydrogen is used for the generator rotor cooling, and the ventilation is done by the axial flow fan, which is connected to the rotor shaft. The generator and the main transformer are connected by the IPB, and the electricity which is generated is boosted up to 525 kilovolts at the 786 megavolt ampere main transformer. Two lines, one is spare line, at the main transformer transmit electricity to the Ungaran substation, and the other two lines transmit electricity to the Japara substation, after being transformed to 150 kilovolts at the interbus transformer. Condenser consists of one shell per unit and gathers the low-pressure turbine exhaust and various types of drain to the hot well after condensing through heat exchange by cold seawater. The condensed water, which is gathered at the hot well, goes through the gland steam condenser and low-pressure feed water heater by condensate extraction pump. Then becomes feed water, which the air and other dissolved oxygen has been removed after going into the deaerator. This feed water goes to the boiler economizer after going through the BFP and high-pressure feed water heater. Seawater is used to condense the turbine exhaust steam. After the waste is removed at the trash rack and traveling dual band screen of the intake, seawater goes to the condenser by two circulating water pumps to cool the turbine exhaust steam. The cooling water, which finished heat exchange at the condenser, emits to the discharge channel along the discharge tunnel. In order to prevent the release of dust produced from burning coal, the exhaust gas of the boiler goes through the electrostatic precipitator to remove the dust by using the static suction force after making the dust in the exhaust gas electrified. This is done by using the corona discharge. Sulfur dioxide of the exhaust is removed by the flue gas desulfurization. By passing the boiler exhaust gas at the absorber, the sulfur dioxide gas of the exhaust gas and the limestone slurry which is sprayed from the top of the absorption tower react each other, so that the slurry absorbs the sulfur dioxide gas and thus discharges the clean gas without sulfur dioxide. The water used at the power plant is produced by a desalination system using seawater, and the wastewater from the power plant is discharged after being purified at the wastewater treatment system. The ash produced after the coal is combusted at the boiler is taken out by the recycling company after it is temporarily stored at the fly ash storage silo.